everyone. My name is Krishna Amin, and I'm a Global Product Manager for QIAseq Targeted DNA portfolio at QIAGEN. Today, I will be discussing advances in targeted sequencing and how those advances can help you accelerate your NGS workflow with the new QIAseq chemistry that I'll be introducing. So with that, I'd first like to read out our standard legal disclaimer. QIAGEN products shown here are intended for molecular biology applications. These products are not intended for the diagnosis, prevention, or treatment of a disease. For up-to-date licensing information and product-specific disclaimers, see the respective QIAGEN kit instructions for use or user operator manual. QIAGEN instructions for use and user manuals are available at www.qiagen.com or can be requested from QIAGEN Technical Services or your local distributor. So for today's agenda, I will first review what biomarker research looks like today and what are some of the challenges in NGS workflows. I will then introduce QIAseq Targeted DNA Pro workflow that addresses these challenges and accelerates your NGS workflow while still maintaining high performance. I will then review some of that performance data with you and then close it with a summary, and then we will take questions and answers. So let's get started with what NGS biomarker research looks like today. So everyone here knows that the detection of several types of biomarkers is a cornerstone of oncology. And in recent years, NGS-based assays are accelerating rapidly in the field of oncology. So there are assays to detect DNA-based biomarkers such as single nucleotide variants, insertion and deletions, copy number variations, TMB or tumor mutational burden, microsatellite instability or MSI, and methylation. There are also RNA-based assays to detect fusion events, exon skipping events, and/or gene expression and microRNA profiling. So NGS is really the ideal technology to efficiently and cost-effectively detect these biomarkers, often simultaneously. For today, we will focus on the DNA-based variant analysis using NGS workflows. So let's start with look at some of the challenges that researchers have to overcome for oncology biomarker analysis. First, the NGS assay development process can be quite challenging. It requires deep expertise in NGS chemistry and bioinformatics. From experience, to go from concept to implementation, NGS assay development can take several months to years, as it might require several iterations and runs to optimize your panel and bioinformatics pipeline. Limited panel sensitivity. This can arise due to PCR artifacts. So traditional two-primer amplicon chemistry often results in PCR duplications. So you're not able to accurately differentiate true variants from false positives. So this results in an inability to confidently call those low variant allele frequencies. Many NGS workflows also require high sample input requirements. And this kind of allows you to not analyze your low yielding or low quality samples such as FFPE or cfDNA. And lastly, library prep is often a multi-day protocol. And this can be quite time consuming and results in a longer turnaround time that often results in an inefficient use of your lab resources and delays in getting results. So let's look at how QIAGEN addresses each of these challenges. With regards to deep expertise required, QIAGEN can provide you with an integrated NGS solution for all your NGS needs, from targeted NGS panels and optimized analysis to interpretation tools. So first, we have QIAseq Targeted DNA Panels that were first introduced to you in 2016. This chemistry provided better coverage of GC-rich regions and enhanced sequencing uniformity due to our optimized PCR chemistry. It also reduced bias and false positives with the incorporation of Unique Molecular Indices, or UMIs. We also have state-of-the-art data analysis options such as CLC Genomics Workbench. CLC Genomics Workbench comes with an easy-to-run analysis with pre-built and optimized QIAseq workflows. These allows you to detect this allows for sensitive variant detections with the tuned algorithms that can process those UMIs. It also provides you with a seamless VCF file uploading for interpretation in our variant interpretation tool known as the QIAGEN Clinical Insight or QCII for QIAseq. QCI for variant interpretation generates variant reports using the vast QIAGEN knowledge base, the biological context for variants, including actionable information, and provides you with full transparency for supporting literature. So really, QIAGEN, again, can provide you with an integrated solution for all your NGS needs. With regards to the limited panel sensitivity, QIAseq technology also enables sensitive and reliable variant detection with an incorporation of UMIs and UDIs to provide you with robust panel sensitivity. By tagging each DNA molecule with the unique molecular index, or UMI, before any amplification has taken place, you can distinguish your PCR-introduced artifacts from true variants. This provides you with a high confidence in variant detection, even at low or low frequencies. Unique dual indices, or UDIs, can help you track each sample with high resolution by ensuring that each sample index combination is truly unique on the flow cell. This provides you with high confidence in demultiplexing your samples by giving you accurate read assignment and maximum utilization of your flow cell. With regards to many NGS workflow requiring high DNA inputs, QIAseq technology has a relatively low DNA input requirement. So you can start your library preparation with as little as 10 nanograms of DNA input, which makes the QIAseq workflows highly compatible with low input samples such as FFPE and cfDNA. And finally, I'd like to introduce QIAseq Targeted DNA Pro, so you can now say goodbye to your lengthy and laborious library prep workflows. With an introduction of enzymatic cleanups, QIAseq Targeted DNA Pro significantly reduces hands-on time that would otherwise be spent on lengthy bead cleanups. By replacing bead cleanups with enzymatic cleanups after ligation and target enrichment steps, the QIAseq Targeted DNA Pro increases the recovery of your DNA molecules. By eliminating custom sequencing primer that was previously required to sequence our QIAseq Targeted DNA libraries on Illumina flow cell, QIAseq Targeted DNA Pro now allows for an easier sequencing setup, but also now allows you to maximize your flow cell by multiplexing QIAseq libraries with non-QIAseq libraries. QIAseq Targeted DNA Pro also comes with easy to automate reagents, and with enzymatic cleanup incorporated, your NGS workflow can now be even more amenable to automation. So with easy to use and fast QIAseq Targeted DNA Pro, you can now really accelerate your time to results. So I will now give you a bit of an overview of what the QIAseq Targeted DNA Pro looks like. So QIAseq Targeted DNA Pro builds on the recognized performance of QIAseq Targeted DNA panels that were first introduced in 2016. And over the last 6 years, we have seen multiple publications that show that UMI-enabled error correction and QIAseq enrichment technology delivered high performance for variant analysis. And now the new QIAseq Targeted DNA Pro will continue to deliver this high performance by leveraging innovations that I mentioned earlier to improve the ease of use and workflow efficiency. So when we look at the impact of the workflow improvements in QIAseq Targeted DNA Pro panels, we can see that the incubation time and hands-on time are significantly reduced compared with the previous chemistry. In fact, they're nearly halved. So with hands-on time of less than 2 hours, the QIAseq Targeted DNA Pro takes you from sample to sequencing-ready library within 6 hours. So this entire workflow can take you sample to sequencing-ready library in just 1 day. So let's take a look at what the QIAseq Targeted DNA Pro workflow looks like. We start with the workflow as little as 10 nanograms DNA input amount. The library preparation starts with fragmentation step. This is in this step, the DNA molecules are enzymatically fragmented and repair and A-tailed within a single reaction. For FFP DNA samples, a repair step is carried out first to make more FFP DNA molecules suitable for library construction. The prepared DNA fragments are then ligated at their 5' ends with sequencing platform-specific adapters. In this step, we tag each DNA molecule with unique molecular index, or UMI, that helps us accurately analyze unique reads for variant calling. For sequencing libraries on thermal platforms, we also assign sample indexes in this step. For sequencing on Illumina platforms, sample indexing is done in later steps. Next, we perform an enzymatic cleanup to purify the libraries. In a traditional library prep method, this would have been a very lengthy bead cleanup. After the enzymatic cleanup, we perform target enrichment using SPE-based panel. Following this step, we will perform another enzymatic cleanup to remove any contaminants and unwanted DNA fragments. We will then perform a universal PCR to optimally amplify library as well as add the sample indexes or UDIs for sequencing on Illumina platforms. And at last, we will perform the one and only bead cleanup step required in the workflow to purify the final libraries. So this entire workflow will take you from sample to sequencing ready libraries in just under 6 hours with less than 2 hours of hands-on time. And this workflow is also very easy to automate. So the QIAseq Targeted DNA Pro also will come with 18 off-the-shelf or catalog panels that will be divided in 3 groups. For somatic variant detections, we have research panels and we have focus panels. Research panels enable analysis of the entire coding regions of relevant oncogenes and tumor suppressor genes implicated in solid tumors and liquid tumors. Focus panels enable analysis of only the actionable and interpretable cancer-related somatic variants in oncogenes and tumor suppressor genes implicated in solid tumor and liquid tumors. For germline variant detections, we also have hereditary cancer comprehensive and cancer-specific panels that analyze the entire coding regions of the relevant oncogenes and tumor suppressor genes implicated in hereditary solid tumor and hematological malignancies. So as of now, we have released the panels for the somatic variant detections, which are the research panels and focus panels. For every research panel, you can also find an equivalent focus panels that targets the same genes, except for focuses on the targeted on the hotspots and actionable variants. The hereditary cancer research panels will be released in April. QIAseq Targeted DNA Pro also delivered high specificity and high uniformity for all research and focus panels that have been released. And looking at the slide, you can also compare the sizes of the focus panels compared to the research panels. Because the focus panels are also targeted only for the hotspots and actionable variants, these panels are relatively smaller than our research panels, which are mostly targeted for the academic and translational researchers. So as with our previous QIAseq Targeted DNA products, QIAseq Targeted DNA Pro also comes with custom panels, which offers our customers flexibility to accommodate new content without compromising on the quality of the data produced for them. So there are 2 ways to creating custom panel. One way is through a GeneGlobe NGS Custom Builder, which is an online tool that allows you to create your own custom panel with our default primer design parameters. Another way to design a custom panel is through our Enterprise Genomic Solutions team. EGS team can provide advanced customization options to target non-coding regions as well as detecting complex variants that go beyond the SNPs and indels. The team also works with customers to ensure that the custom panel design is customized to their NGS workflows. So if you need help designing any of the custom panels, feel free to reach out to your sales reps, and one of the EGS team member can get in touch with you. So the complete QIAGEN sample to insight procedure begins with DNA extraction using one of our QIAAM kits that's suitable to your samples. Next is the library preparation and target enrichment with QIAseq Targeted DNA Pro panels and platform-specific index kits. Libraries generated can be sequenced either on Illumina or Thermo Fisher sequencers. Data analysis can be performed using our commercial-grade QIAGEN CLC Genomics Workbench, which not only enables the detection of SNBs, indels, and CNBs, but also the structural variants with known breakpoints, as well as chromosomal deletions. And then the detected variants can then be interpreted with QIAGEN Clinical Insight Interpret for QIAseq. So let's look at some of the performance data produced out of QIAseq Targeted DNA Pro. So in this and the next slides, I will review some data that we collected internally to show how QIAseq Targeted DNA Pro remarkably improved the UMI capture efficiency compared to our QIAseq Targeted DNA panels. So here we used 6 DNA samples of varying degradation from archived FFPE tissue samples. Libraries were generated using both QIAseq Targeted DNA panel as well as an equivalent QIAseq Targeted DNA Pro panel. DNA input amount was 100 nanograms, and libraries were sequenced using MiSeq. The data was analyzed using UMI-aware variant calling pipeline. So as you can see on the chart on the right, the QIAseq Targeted DNA Pro workflow significantly increased the efficiency of capturing more unique DNA molecules from FFPE DNA samples than our QIAseq Targeted DNA Panels workflow. So we can see that it's more than double the number of UMIs that are captured with the Pro workflow compared to the QIAseq Targeted DNA. QIAseq Targeted DNA Pro also improved the UMI capture efficiency in both fresh and cfDNA samples. So here we used fresh and cfDNA samples, and the libraries were generating using both QIAseq Targeted DNA panel as well as an equivalent QIAseq Targeted DNA Pro panel. DNA input amount here was 10 nanograms, and libraries were sequenced using MiSeq. Data was again analyzed using a UMI-aware variant calling pipeline. So again, as you can see on the right, the QIAseq Targeted DNA Pro again significantly increases the efficiency of capturing more unique DNA molecules from both high-quality DNA as well as cfDNA samples in our QIAseq Targeted DNA Panels workflow. So by increasing the UMIs captured, the new workflow enables detection of low variant allele frequencies with high performance. I will now present you with some data that were collected by 2 external labs that ran QIAseq Targeted DNA Pro myeloid neoplasms focus panel. So in the next 3 slides, I will review the data set collected by a lab at King's College in the UK on liquid tumor samples. This lab analyzed 11 DNA samples from bone marrow and a Horizon Myeloid DNA reference standard known as HD829. Libraries were generated using QIAseq Targeted DNA Pro myeloid neoplasm focus panel. This panel targeted hotspots and actionable variants in 70 genes relevant to myeloid neoplasms. DNA input amount varied from 40 to 100 nanograms. Libraries were sequenced using Illumina NextSeq, and the data was analyzed by QIAGEN using CLC Genomics Workbench QIAseq Targeted DNA Pro plugin. So as you can see on the charts on the right, the QIAseq Targeted DNA Pro achieved high enrichment specificity of greater than 94.5% on all samples, as well as high uniformity of coverage of greater than 99% across all samples tested. So let's first review the variant analysis of HD829 with QIAseq Targeted DNA Pro from the dataset that we discussed earlier. So myeloid neoplasms, our focus panel included primer coverage across 20 out of those 22 variants that are present in HD829. And as you can see, chart on the right, we were able to successfully detect all of the somatic variants that were present at 5% variant allele frequencies, as well as all of the germline variants or variants greater than 10% or equal to 10%, so at the expected variant allele frequencies. Not only that, but we were also able to detect the FLT3 ITD mutation at the expected frequency. The lab also analyzed DNA samples that were previously genotyped using our QIAseq Targeted DNA panels. And as you can see in the table on the right, there were 5 samples that were positive for several variants with different variant allele frequencies. And with QIAseq Targeted DNA Pro, we were able to accurately detect all of those variants at the expected frequencies. Another lab another lab that's based in the US also generated libraries using QIAseq Targeted DNA Pro myeloneoplasms focus panel on 8 different Coriell cell lines, HD799 and HD829, which are Horizon reference standards for FFPE and myeloneoplasms. The DNA input amount they used was 40 nanograms, and the libraries were sequenced using Illumina NovaSeq. Data was analyzed by QIAGEN using CLC Genomics Workbench. And as you can see on the charts on the right, QIAseq Targeted DNA Pro again achieves high enrichment specificity and high uniformity of coverage, greater than 94.5 and 99% respectively. In the next 2 slides, I will review the data on HD799 and HD829. So let's first take a look at HD799. The QIAseq Targeted DNA Pro myeloneoplasm focus panel covers 8 out of the 11 variants that were present in HD799. And we were able to detect all of the 8 variants at the expected variant allele frequencies. Not only that, but we were also able to achieve high sensitivity in detecting the variant in EGFR that's present at 1% variant allele frequency as expected. So when we compare the data collected by both of these external labs on HD829, we found that QIAseq Targeted DNA Pro achieves reproducible and robust panel sensitivity in detecting all of the variants that were covered by the panel. So we have a strong correlation between the 2 labs that were that ran the workflow independently in 2 different instruments in 2 different continents. So to kind of summarize, QIAseq Targeted DNA Pro can accelerate your journey to high-quality results by providing you with the sample-to-sequencing ready libraries in less than 6 hours. With their improved workflow and increased UMI capture efficiency, you can now also detect high sensitivity, or you can also detect low variant allele frequencies resulting from challenging samples. And as we saw in the results in HD799, we also have high sensitivity for detecting low variant allele frequencies using QIAseq Targeted DNA Pro workflow. And that is the end of my webinar. Thank you for your attention. And if you have any questions, please type them in the Q&A box, and I will take your questions one by one. Let's take a look at the first question we have is, are the old QIAseq panels going away? No, the old QIAseq Targeted DNA panels that were previously released in 2016 are not going away. We're continuing to provide support for QIAseq Targeted DNA panels as well as QIAseq Targeted DNA Pro panels. So if you have a workflow that's locked in, don't worry, the panels are not going away. We have a question on high for cfDNA. What is the LOD for allele frequency? Our current recommendation for cfDNA is to use as much as I don't know the DNA input amount, but we do recommend with 40,000 X coverage, you are able to achieve the variant allele frequency of down to 0.5%. Could the QIAseq Targeted DNA Pro technology be applied to detect fusion genes? At the time, we've only tested the QIAseq Targeted DNA Pro for DNA-based variants. We've not yet tested the technology on RNA-based biomarkers. On the performance with less than 10 nanograms of DNA input, we actually saw comparable performance with 1 nanograms with 10 nanograms DNA input amount. However, when we want to target the low variant allele frequencies, we do need to input a higher DNA input amount, at least greater than 10 nanograms. So I think that are the panels also compatible with thermal sequencers? Yes, the QIAseq Targeted DNA Pro is also compatible with both the Illumina and Thermo Fisher sequencers. QIAseq target focus panels are built on variants identified in which population for germline mutations. So the QIAseq focus panels are actually only focused for the somatic variants that were for the genes that are implicated in solid tumor and liquid tumors. Is there an extraction kit from fresh tumor samples? I believe there is you can use the QIAamp mini prep kit to extract DNA from fresh tumor samples. Mentioned that the workflow is easily automated. Does QIAGEN provide a validated method script for Hamilton line of star automated liquid handlers? Yes, this is currently in development. We will have, we are working on developing the automation script for QIAseq Targeted DNA Pro on Hamilton NGS star. So we will have a method script for that. Are you going to make a panel for kidney cancers? So I believe our kidney cancer is part of the comprehensive cancer panels for any genes that, any panel that we currently do not have off the shelf. We also have the ability to customize the panel. So you can always customize the panel to your specific biology of question. QIAseq Targeted DNA Pro available as QIAseq Targeted Custom Panel. Yes, QIAseq Targeted DNA Pro also have a custom design options as well. Has enzymatic, sorry. There was a question on enzymatic cleanup, sorry. Could you describe the enzymatic cleanup process a bit more? So enzymatic cleanup basically replaces the bead cleanup steps to allow to remove any contaminants from your library prep. It essentially does the same thing as the bead cleanup step, except gives you a higher DNA recovery, because during the bead cleanup steps, you tend to lose your DNA molecules quite a bit to the beads. With incorporating your enzymatic cleanup, you can now have a higher recovery of DNA molecules. Can you give more details regarding the hereditary cancer research panels? The hereditary cancer research panels, I will go back to the slide deck here. So the hereditary cancer research panels, again, will have the comprehensive cancer research panels that will include all of the cancer-specific panels as well as more. But these are looking at specifically genes that are implicated in for germline variants implicated in solid tumors and hematological malignancies. We will release the panels and the bed files and the ROI files in April 22. So, stay tuned for that. Can we mix libraries from different panels in the same run? Yes, so because of the removal of custom sequencing primer, you can now mix libraries from different panels on the same run. What is the major difference between QIAseq and QIAseq Pro? Only the cleanup steps. The difference between the QIAseq and the QIAseq Targeted DNA and QIAseq Targeted DNA Pro is not only the cleanup steps, but we've also incorporated fast cycling enzymes to reduce your incubation time by nearly half. In terms of being able to, in terms of being able to sequence the libraries on a flow cell, we've also removed the custom sequencing primer, so you can now maximize your flow cell to multiplex QIAseq libraries with non-QIAseq libraries. We've also reduced the viscosity of some of our reagents, which made the previous workflow a little bit difficult to automate. So with the reagents having reduced viscosity, not only the reagent, but the whole overall workflow is also easier to automate. There's a question on custom panels. Yes, the custom panels are available. As I mentioned, there will be essentially two ways to create your custom panel. You can create your own custom panel using our GeneGlobe QIAseq Targeted DNA Pro custom panel, or you can work with our team of genomic experts who can work with you to develop a custom panel. Can you design high-quality DNA panel that focuses on CpG islands? So we do have another product portfolio, QIAseq Targeted Methyl Panels, that focuses on the CpG islands. That workflow is not compatible with QIAseq Targeted DNA Pro, but we do have an NGS solutions that's specifically looking at CpG islands. Is it possible to mix FFP and cfDNA in the same run? Yes, this will be possible to mix the FFP and cfDNA samples in the same run. Can you send the differences by email, or is it already available on the website? We can certainly send you the differences by email. Just feel free to reach out to your local sales rep, and we can get you the differences. The product web page is also going to be live soon, so you'll be able to find those differences online as well. When is it available to order? The QIAseq Targeted DNA Research and Focus panels are available to order now. The custom panels are also available for ordering. The hereditary cancer research panels will be available in April, but the other panels are currently available. We are using custom panel for both DNA mutation and RNA fusion. Could my custom primers be translated to QIAseq Targeted DNA Pro? We can take a look at your QIAseq Targeted, the DNA panel, DNA primers, and we can make the primers compatible with QIAseq Targeted DNA Pro. However, it does require a redesign of the primers because we want to make sure that the primers are also optimized for the newer chemistry. Regarding the input in the case of mixing the FFP and cfDNA samples, you can find more information on this in the handbook for QIAseq Targeted DNA Pro. If the previous version is under accreditation in the lab, do you have special instruction or consideration to go with the Pro easily? Some steps to consider. The QIAseq Targeted DNA Pro does offer ease of use, and it does include, it is relatively short, so if it's under accreditation and you need to change, if you would like to change to QIAseq Targeted DNA Pro, then we can work with you to give you a QIAseq Targeted DNA Pro that's compatible with the ROIs that you're currently trying to detect. Upper limit of primers for custom panels. Currently, upper limit of custom primers is 20,000 primers, so you can target 20 up to 20,000 amplicons with the QIAseq Targeted DNA Pro. Has enzymatic fragmentation or cleanup shown any evidence of sequence selection bias? So far, we have not seen any evidence of sequence selection bias with enzymatic fragmentation. In fact, it gives you non-biased uniformity of coverage across all your regions. There's a question on switching the new chemistry version to redesign the primers. The QIAseq Targeted DNA Pro does come with the primer design that's optimized to match the QIAseq Targeted DNA Pro. Again, this is something that we can work with you on whether or not your panel will require complete redesign or not, but this is something that we can work with you. So if you have any questions or concerns regarding that, feel free to either reach out to me or your local sales rep, and we can take that offline and figure out a panel that works best for your needs. Do you expect Fusion panel with the QIAseq Pro technology be available in the coming future? When? We currently do not have have it on the roadmap to have the QIAseq Targeted DNA Pro available for the fusions. Which is the input in the case of mixed FFP and cfDNA? Any special advice? Again, you can find that information in our handbook. We're happy to share that information with you over email. I think I may have answered all the questions. We'll give everybody a few minutes to ask any other questions that they may have. In case I've not been able to answer any of your questions, feel free to reach out to me with any questions or concern, or you can also reach out to your local sales rep who knows how to get in touch with me for any questions or concerns.
QIAGEN.
Sample to insight.